Our next method we are going to use is called the grouping method. We are going to use the grouping method when you're factoring 4-term polynomials only. The steps are: step 1, group the first 2 terms and the last 2 terms. You could rearrange the order, but I usually don't. I just group the first 2 together and the last 2 together. If that doesn't work, then I go back and reorder them. Step 2, factor out the GCF from each group independently. So factor out the GCF for the first 2 terms, and then factor out the GCF for the last 2 terms. If the remaining factors match from both groups, then factor out again the GCF from both groups. Factor further if necessary. So when do you want to use grouping? We only use grouping when we're factoring 4-term polynomials. This is the only time grouping is actually going to work. So on these examples, you want to factor out the polynomial using grouping. So I'm going to factor the first group in blue and the second group in red. So you might want to just take your fingers and cover up the red group so that you don't see them at all. Just looking at the blue group only. What is the GCF that can come out of 10HN and 3KM? Well, it doesn't look like there can anything be factored out of there. Now let's look at the red group, 2HM and 15KN. Nothing can be factored out there either. So this is one of those examples where I just take the first 2 and make them a group, and second 2 and make them a group, and it didn't really work. I can't take a GCF out of either group. So what I want you to do is rearrange this into a group that does work. So with the 10HN, which one of these terms has common factors with 10H and N? Well, to me it looks like 2HM works. This is not the only way, but this is one way. So all I really did is I switched the 2 middle terms. Notice the 2 was positive 2HM, so it stayed positive 2HM, even though I reordered it. The negative 3KM was negative, and it stayed negative, even though I reordered it. Now I'm going to regroup with my red and my blue. So in the blue group in the front, 10HN and 2HM. What is a GCF on the blue group? Well, it looks like 2 is common and H is common. So when I factor out 2H, I'm getting 5N plus 1M. Okay, at this point I can go back and erase my 1 because I don't really need it, but I like to have it there until I know that I have a variable after it. Now let's look at the red group and the negative 3KM and a negative 15KM. Now I said anytime you have a negative in front of the polynomial, you want to factor out a negative. Well, that works for groups here as well. But in the red group, the first term is negative. I want you to factor out that negative sign. The GCF between 3 and 15 is 3. And the GCF between KM and KN is K. So negative 3KM divided by negative 3K is positive M. Negative 15 divided by negative 3, that's positive 5. Kn divided by K is just N. Are these two parentheses truly equal? Well, 5N plus M and M plus 5N, they sure are, but I'm going to go ahead and take one extra step just to ensure that they are equal by rearranging one of the terms like we did in the GCF problems. So if I rearrange M plus 5N, I can get 5N plus M. Are these truly the same? Sure they are. When there were minuses in here and you rearranged it, they weren't quite the same. So just be careful when you rearrange it that you are truly making sure that they're equal before you factor them out. So now I can see that these parentheses are equal. So my next step will be to factor out 5N plus M. And when I factor that out of both of the terms, there was one long term here and one long term here, what do I have left? Well, I have left 2H on the first term, And on the second term, I'm left with minus 3k. This is the factorization of my original polynomial. If you have room to work it out on your paper, you can distribute this polynomial and truly make sure that it distributes out to the original problem. On my next problem, I always just take the first two as one group and then the second two as one group until it doesn't work like we did before and we had to rearrange. But I'm pretty lazy, I just group the first two just to see if it works. And most of the time it does. So I have negative 42 and positive 6. The GCF there looks like negative 6. I have to factor out the sign of the leading coefficient of each group. So this leading coefficient is negative, so I have to factor out a negative. So between the x's, I have x squared and x squared. I can factor out an x squared out of each. And between the z's, I have z cubed and z squared. I can take out a z squared of each. Again, I'm looking for the lowest coefficient. Negative 42 divided by negative 6 is positive 7. X squared divided by x squared is 1. I don't need to write it because I already have a 7. Z cubed divided by z squared is z. Positive 6 divided by negative 6 is negative 1. X squared divided by x squared is 1. I don't need to write it because I already did write 1. Z squared divided by z squared is 1. So it looks like my inside parentheses is just 7z minus 1. On my red parentheses, I have a negative 2 and a positive 14. But because my leading coefficient of the group is negative, I'm going to factor out a negative. And between the variables x z cubed and x z to the fourth, I have an x in common and z cubed common. So negative 2x z cubed divided by negative 2x z cubed. A negative divided by negative is a positive. 2 divided by 2 is 1. X divided by x is 1, so I still have the 1 there. Z cubed divided by z cubed is 1. I still have the 1 there. Positive 14 divided by negative 2, that's negative 7. X divided by x, that's 1. Z to the fourth divided by z cubed, well, that's z. Are these two parentheses the same? Well, they're not quite the same. They're backwards, aren't they? So just like in the last problem, I'm going to rearrange. I like to have the variable in front, so I'm going to keep the first one the same in the blue, but in the red, I'm going to rearrange to have the negative 7z in front and the positive 1 in back. Now, the two parentheses do not look the same. This one's positive 7z minus 1, and this is negative 7z plus 1. So what I can do is I can factor out a negative in the red group, which leaves me with negative 1, and when I factor that out, I'm getting a positive 7z. Positive 1 divided by negative 1 is negative 1. Now I still have that being multiplied by all of the other red terms, which really gets me a negative times a negative, or a positive 2x z cubed. And the blue stays the same. And out of these two terms, it looks like I have a GCF of negative, because the first term is negative, so I'm going to factor out a negative. 2, there is an x common, there is two z's common, and it also looks like these parentheses 7z minus 1 is common. I have two terms left, the blue term left and the red term left that I need to write. So negative 6 divided by negative 2, that's positive 3. X squared divided by x, that's x. Z squared divided by z squared, that's 1. I don't need to write it. The parentheses divided by the same parentheses, that's 1. I don't need to write it. On my next term, positive 2 divided by negative 2, that's negative 1. X divided by x is 1. I don't need to write it. Z cubed divided by z squared, that's z. At this point, I could go back and erase my 1 if I really wanted to. And 7z minus 1 divided by 7z minus 1, that's just 1. Again, I don't need to write it, I already have terms there. So this is my factorization. That was a good problem. On my next problem, I have the first two in my blue group, the second two in my red group. So I have x squared common in both of the terms in the blue group, which leaves me with x plus 8 in the parentheses. In my red group, notice my first term in the red group is negative, so I know I'm going to be factoring in a negative. The GCF between 5 and 40 is 5. And what do I have left on the inside? Negative 5x divided by negative 5, that's positive x. Negative 40 divided by negative 5, that's positive 8. Are the two parentheses the same? Well, they sure are. So I'm going to factor out the x plus 8. And what do I have left? Well, I have x squared minus 5. There's nothing else that can be factored out of either of these, so we know we are completely factored. In my next problem, I'll take the first two and make them the blue group, take the second two and make them the red group. In the blue group, I have a GCF of, well, nothing between 7 and 21 other than 1. I'm not going to take a 1 out of a GCF, that's not necessary. Between x and x, there's a GCF of x, and between y cubed and y, there's a GCF of y. So what do I have left when I take out an x and a y? Well, in the first term I have 7. X divided by x is 1, I don't need to write it. Y to the third divided by y is just y squared. Minus 20 divided by 1, well that's just 20. Xy divided by xy, that's 1, I don't need to write that. On the red group, I have positive 2 and negative 70. Because the 2 is positive, I'm going to be factoring out a positive. Please write that positive sign there. Normally, you don't have to factor out a positive sign, but because it's the second group, you do need to put a sign there. Otherwise, it would mean multiply, and that's not actually true. So make sure you put whatever sign you're factoring out of the second group, you need to write it even if it is a positive. The GCF between 2 and 70 is 2. The GCF between y cubed and x squared y is just y. So that leaves me with y squared minus 35 x squared. Now, are these two parentheses the same in the blue group and the red group? 7x squared minus 20 and y squared minus 35x squared. No, they're not even close at all. They're not off by a negative. They're not, I didn't just forget to factor it out. They're way, way off. There's nothing that I can do about that. I need you to understand that this is not my fault. Okay? We tried it. We tried the first two terms together. We tried the second two terms together. It just didn't work. So what I'm going to do is I'm just going to take my 4 terms and rearrange them in a different manner. So I get to decide which way I want to rearrange them. So I'm going to start with the first term, 7xy cubed. And I want you to pick another term that has at least something in common. To me it looks like the 2y cubed, that both of them have y cubed. So let's go with that. And then I'm going to put the next two down in either order, really. At this point, I'm not sure which order is better, so I'm just going to guess. So I'm going to group the first two in blue, the second two in red. In the blue group, it looks like I can factor out a y cubed. And I'm left with 7x plus 2. In the red group, I can factor out a negative, because the first term is negative. Out of 20 and 70, I factor out a 10. Between xy and x squared y, I can factor out an xy. And that leaves me with negative 20 divided by negative 10, that's positive 2. Xy divided by xy, that's 1. Negative 70 divided by negative 10 is positive 7. X squared y divided by xy, that's x. Now these two parentheses look the same, but just to make sure, I'm going to rearrange them to have the x in front. So the blue terms stay the same, but in the red, I'm going to rearrange them 7x plus 2. The two parentheses now truly are the same, 7x plus 2 and 7x plus 2. So I'm going to factor out the 7x plus 2. And what do I have left? I have the blue y cubed, and in the red I have minus 10xy. And I'm done, right? Oh, so close. I'm almost done. Here's the reason why before I might have been done, but I'm not done on this particular problem. 7x plus 2, there's nothing else that can be factored out there. That's completely factored. But on the second term, y cubed and 10xy, do you see how they both have a y in them? So because they both have a y in them, I'm going to factor out a y, which leaves me with y squared minus 10x. And that purple 7x plus 2 is just going to stay the same. At this point, now I am truly 100% factored out because y can't be factored anymore, 7x plus 2 can't be factored anymore, and y squared minus 10x cannot be factored anymore. Now I am completely factored.